Hi students, welcome to this video. I am A. Samuel Silvan, Department of Physics. Students, in this video, we are going to discuss 8th Standard Physics, Chapter 4, Energy. The learning objectives are power and unit of power, difference between energy and power, and finally we are going to conclude with some numerical problems. Students, first we are going to discuss about power. What is power? Power is the rate of doing work or transferring energy. So students, for your understanding, I am going to tell you one illustration. Two boys are swimming in the swimming pool. So the boy A reaches first. Within 5 minutes, he reached that destination. But the boy B reaches the destination after 2 minutes later. For example, A reaches within 5 minutes and B reaches 7 minutes. Why these differences? Because the boy A has more energy than B. So from this we can easily conclude with another one example. We can take one two-wheeler and one car. Which one is go faster? Absolutely car go faster because the engine power of the car is very high. So from this we can easily understand power is the rate of doing work or transferring energy. So next we should know the students unit of power. What is the unit of power? So students, power is related to rate at which work is done. For example, power is equal to work done by a body by time taken. Already we know the students what is work done. Work done is depends upon force into displacement or force into distance. So power is equal to work divided by time. So power is also depends upon work and time. So finally we can write like this: W is equal to J divided by S. J means joule. So what is the S unit for the work? The S unit for work is joule. That's why we written like this joule. This indicated as J. So J by S. S means time. So student, next we should know the SI unit of power. The SI unit of power is joule per second. That's mean J divided by S. It's also known as watt. Okay, WATT. So SI unit of power, if they are asking SI unit of power, we have to write watt or joule per second. So 1 watt is equal to 1 joule second power minus 1. So division S is comes to the multiplication. We have to write like this: S power minus 1. So students, next we should know the bigger unit of power. So bigger unit of power we have to write like this: kilowatt. So 1 kilowatt is equal to 1000 watt. Kilo means 1000, we have to keep it in our mind. Kilo means 1000. So 1 kilowatt is equal to 1000 watt. So student, next we are going to discuss about difference between energy and power. Already we discussed many times about energy and power. So here also we are going to compare energy and power. Already we know about energy. So now we discussed about power. So both we are going to compare. So see this the table energy and power. You can see the first point, energy is defined as the capacity to do work. That's mean ability to do work. You can see that the definition for power. Power is defined as the rate at which work is done or energy is transmitted. So second, you can see the second point, energy can transform one form to another. Already we know that. Already we discussed many examples. For example, light, okay, bulb, how it glows, electrical energy converted into light energy. So energy can transform from one form to another, but power does not transform forms. Okay, already we know that power does not transform forms. So you can see that the third point, we can store energy that is generated. How we can store the energy? For example, solar panels. So solar panels gets light from the sunlight. It's converted into electrical energy. It's stored in the battery. So from that battery we can use in our home. Okay. So power. So energy can stored. So but power cannot be stored. So power we cannot be able to store at any places or any devices. So you can see that the fourth point, it is very important one, that is SI unit of energy. Already we know that the SI unit of energy is joule, but the SI unit of power is watt. So we have to keep it in our mind. SI unit of energy is joule, the SI unit of power is watt, or we can say joules per second. Okay students, next we are going to do some numerical problems which is given our book in the last pages of the this lesson. uh, so first numerical problem, what they are given here: a force of 5 newton when applied to a body displaces it 2.5 meter. Find the amount of work done in this process. So we have to find out the work done. Students, already we know that the formula for work done. So first I am going to write the formula. Solution: work done formula is W is equal to F into S. F means force and S means displacement. So I am going to apply these values into that formula. 5 into 2.5. 5 is the force and 2.5 is the displacement. So after multiplication we can get 12.5 joules. So from this we can easily get the work done. The work done is 12.5 joule. Okay, next sum. Next numerical problem. A body of mass 4 kg is moving with velocity 5 meter per second. Calculate the kinetic energy possessed by the body. So students, we clearly know about the kinetic energy. Kinetic energy formula also we know. Okay, so first I am going to write the solution. Kinetic energy is equal to 1 by 2 mv square. So I am going to apply these values into the formula. 1 by 2 into mass is 4, so I'm going to write 4 into velocity is given here 5. Velocity is v squared, so we have to write twice. 5 into 5. For example, if they are given 7, 7 to 7. If they are given 9, 9 to 9. So twice we have to write. So I'm going to cancel 2 and 4. So cancel out, we can get 2. So 5 into 5, 25. 25 into 2, 50 joules. So next, third question. What is the kinetic energy of 35 kg object moving at the velocity of 12 meter per second? So here what they are asking, kinetic energy. So same like that we have to write the formula. Solution is equal to kinetic energy is equal to 1 by 2 mv square. So of mv square we have to write the apply these values in the formula. Half into 35 for mass, and velocity is they are given here 12. So we have to write it twice because v square. So after multiplication and division we can get the answer 2520. That's means 2520 joule. So finally we can get the kinetic energy of the energy possessed by the body is 2520 joule. And next, the fourth sum. A 45 Newton object is lifted to a height of 4 meter. What is the gravitational potential energy of this object? So what they are asking here, gravitational potential energy. Already we know that the formula for gravitational potential energy. What is the formula? Potential energy is equal to mass into gravity into height. But here they did not give mass and gravity. Other than they are given here Newton means weight. They are given here weight. So we have to rearrange the formula. Mass into gravity is equal to weight. So I am going to rearrange the formula. Weight into height. So I am going to apply these values in the formula. 45 into 4. So finally we can get the potential energy is 180 joule. So finally the gravitational potential energy of this body is 180 joules. Let's see the fifth sum. What is the force applied on your body when 200 joule of work is done in displacing the body through a distance of 20 meter in the direction of the force? So first we have to write the formula for this. So W is equal to force into S, because they are asking here work done. So I am going to write the work done. Work done is force into displacement, but the work done is they are given here. So I'm going to write the values of work done 200 joule, but they did not given here force. They only given distance. So I'm going to write this distance 20. So we have to rearrange the formula. How we have to rearrange it? So F is equal to W divided by S. So I'm going to apply these values like that. So F is equal to 200 divided by 20. So cancel out 0 to 0. So 2 into 20, when it is cancelled, answer is 10 Newton. So finally we can get the force applied on the body is 10 Newton. So students, we are going to see the last numerical problem, sixth numerical problem. A force of 125 Newton acts on a body of mass 10 kilogram and produces a displacement of 12.5 in its own direction. Calculate the amount of work done. So we have to write the work done formula. So W is equal to F into S. So F is 125 and S is 12.5. So after multiplication we can get 1562.5 joule. So the amount of work done is 1562.5 joule. Okay students, thank you for your listening.